just hit the camera and it will show what I'm explaining, and hopefully it's gonna be beneficial for the kids. Kids are still, that doesn't mean if you have the recording, you shouldn't show up. Recording is only a reference for you to review, because you've got two type of in-class activities which needs your presence to collect the mark, because I know you love marks. Some of you, I would say most of you, are just doing this stuff to collect grade and then have maybe some license or something, which I don't think that's helpful to only have the license, but I respect your choice. So in order to, while I'm doing this stuff, I'm doing 100 things. In order to complete this course, we have few methods, or I would say few options to complete every step and go from there. During the lecture time, every week, you are gonna have quiz. Quizzes are gonna be by 1 week off. Today, whatever I'm talking about, I don't quiz you today. From next week, I quiz you about the content of today. Welcome. And we continue the same. Week 3, I quiz you for week 2. Week 4 for week 3. So I always give you 1 week to review the content of the lecture or whatever I'm sharing during that week. Bring it to my attention if you have any question, if you need extra clarification. And during the quiz time, weekly quiz time, it's gonna be just 5, or I would say sometime 10 maximum multiple choices question. It's not written quiz, the first version of it. You can see all of those information right in here. I'm gonna bring it up. Also, I have included the link for course outline and the course schedule, which is the requirement about the course. You can also find them under content. And of course, remember to have your fully charged devices, either laptop, cell phone, tablet, whatever electronic devices that you can connect yourself to the internet during the class time. Because the quizzes are online on Avenue, you need a fully charged device to be able to finish it. It's not written. You are not going to do it on some of them. Yes, I'll tell you. Course outline is here. Let's go through it together. This, I would say this session is one of the most important sessions for this course, because all of the requirements are given to you right now. So, here, in the course outline, you can see that you have 2 lectures during the week. A 2-hour today. May I have your attention? I promise to pause, not to talk, and let you talk after I'm done with this one. You don't want to miss it, right? So, and then we will see each other again on Thursday. So I'll see you Monday, Thursday, some of you Tuesday for lab, only 1 section Friday for lab. This semester, usually I don't start the lab from first week. I push it to the 2nd week, but this semester, after years and years, since we have more students than regular, than usual, we have 1 extra section, which is the Friday section. That's why we have to start the labs from tomorrow. Officially, we are having Gurjab. It was Gurjab your name? No? Okay. I thought your name is Gurjab because somebody emailed me that he's not going to show up today. I thought it was you. And then that's why we have to start labs from tomorrow. And we have to finish on the week of March 30. Right? Classes are going to be officially finished by April 7. I've already included in here. So we have in here 13 weeks. We are gonna have 2 sections, embedded system and then automotive electronics. So for the first, and of course in here you can see that I already included even all the breaks and midterm exam and everything included right in here. But first let me finish this one. These are the weekly modules that we are going through them. Some of them we may continue practicing in 2 weeks because it's a longer one, it's a deeper one. Some of them is going to be ended in only 1 week. So we are going to have also 8 labs. During this 8th lab, first one, which is going to be tomorrow, is more focused on what software we need, how you have to just start working with the software. I'll teach you everything. I'll walk you through the steps. I'll help you on the screen. I'll get you to practice inside the lab to just completely be familiar with what you need. And then from lab 2 is going to be experimental. I'll give you setup and I'll get you to just demo your knowledge using those setups. Every week, if you attend to the lectures, I explain the labs, even the solution to labs, during the lecture time. Therefore, you are not alone. You are not expected to be a genius to do those labs. You are not expected to be an expert. You are not yet. You are going to become soon. Therefore, I don't expect anything which is not given to you before. It's normal. It's unfair. I have to first teach you, then assess you. So, nothing is difficult. Nothing is complicated. So many other students in this class did it before. So many. For years, I'm teaching this course and even more advanced grad courses in this field. Therefore, if others did it, you can do it. That's the first thing. No stress. I'm here 100% supportive. I'll give you more than enough solve problem, tutorial, preparation for tests, test 1, test 2. I'll give you enough time to assess yourself, to consult your understanding with others. Therefore, if you do all of the things that it is planned with science and mind and wisdom, 100% successful. If you skip some of them and you want to adjust it, I cannot guarantee anything, right? Because everything is linked. Your lectures and labs are linked. You will be assessed during the test 1, test 2 final exam based on the knowledge that I'm sharing with you during both lecture and lab. So there are lab questions, even in your final exam. Therefore, try to learn every dot first and then how to connect the dots. If you skip some of them, there are some blank spots in there. Then you are going to have some complicated situation. Otherwise, believe me, everything is understandable, doable. We can do it together. So then you are going to have lab projects. You have only one project. Likewise, what we did in mechatronics, in there you have 2. In here you have 1. And it has a good portion of your final grade. Therefore, I plan to push one of the lab projects to the first half of the semester. As I know, you kids love to push everything to the end of the semester, and then you are stuck in middle of lots of complicated things in this course, that course, the other course. Therefore, I pushed one project session to the first half of the semester. You can see it right here in the course schedule. While even we are not done, I'm having one session in week 6, and I get you to put together your project proposal. 100% you can do it at home, but still I'm gonna walk you through the step, help you in here. While you are preparing your proposal, I'll get you to bring some information together, and of course, prepare any requirement for your final project in week 6, right before you go for your midterm break. This way, you don't push everything to the end of the semester and make it complicated. In here, what is the project? The project is going to be a summary of everything that we do during the lab time. Each lab has a portion in the final project mark. And I advise you, I request you, please learn every single lab and learn how to connect them together. That's it. Just connect the dots together, create a final project. Get one portion from lab, to another from lab 3, which is analog to digital. Then a little bit later, you are gonna learn about PWM. Then later about how to program keyboard, how to program LCD, about CAN communication, right? So all you need is learn every single lab, and you don't need any innovation. Just connect those labs to combine them. Very similar to mechatronics, but even a bit more easier because we are following the same structure. In there, we had two different things to learn, microcontroller and PLC. In here, everything is microcontroller. We have nothing to do about PLC, right? And we are going to use the microcontroller, which is the one that every practical automotive industry, like even Tesla, even Mercedes, even like BMW, all of them are using the same microcontroller for automotive. And I'm gonna use the exact same microcontroller, okay? So whatever you learn in here, it is going to be exactly what you are going to practice if you are going to industry right after here, automotive industry, right in there. At the end of this semester expectation, you will be able to program how your wiper is working. You will be able to program how your like turn light or flashes or signals, signal left, signal whatever you want to call it, signal right, it works. How to speed up from brake, how to speed down from highest speed, means how to control your DC motor. You are gonna learn even how to monitor information on the LCD a little bit. You learn maybe some basic one on microcontroller, which we were using in previous course, but a huge difference in here, more advanced. We are not using any complicated language. We use C. C has a little difference with what we practice in C++ first semester, but it's still understandable, very similar. A structure is very similar, okay? So those are the things. During the break, and I would say closer to the end of the previous semester, I've collected lots of email, or not lots, actually some. Kids, remember, this is educational environment, but regardless, even in real world, nobody give us anything for our effort, although our effort is valuable. But effort alone doesn't have mark. Just any effort that can generate result has mark. I don't mark your effort, I mark your result. Make sense? Therefore, I want you to develop this mindset that I'm not supposed to expect any mark because I did a lot of effort, although I have no result. I don't want you to develop a mindset to waste your life with hard working. I want you to plan for smart working. Smart working means even if you do a portion of a project, half of a project, 1/3 of a project, but for that 1/3 of the project, show some result and then expect some mark for it. Most of you didn't follow this procedure last semester, not most, some of you. I would say I'm really honest. You guys are one of my best students. I said it last semester. I repeat it. I really mean it. There are days I meet 1,000 students. Believe me, 1,000 is too many a student, too many people. So I'm interacting with too many people because of my job, not because of anything else. Therefore, I trust you are the best, I would say, generation of students. Trust yourself, you can do it. Trust your heart, you can do it, okay? Learn smart working, not hard working. Nobody will compensate our hard working, even myself. I used to have that mindset. I hurt myself too much. It took me a lifetime to learn. It's not about hard working, it's about smart working. So I share it with you from heart. Learn to split your task to a smaller portion, get that done, show some result, then move to the next. I said it last semester, I repeat it. It's the same procedure. Keep practicing smart working and move from that wrong mindset of hard working. It's not something that we can be proud of. I did it myself. It won't take you anywhere. It's just wasting your life, your youth. Don't do that, okay? Nobody taught me how to do smart working, to be honest. Until I exposed myself to medical science, neuroscience, this and that, to learn is not about hard working. We have been fooled the entire lifetime. It's about the smart work. I just stopped this right in here because we have a lot to share. That's about the expectation for that project are going to be group. It's totally your choice to choose your partner. I leave it to yourself unless somebody come to me and say, hey, I don't have a partner, help me. Then I see if there is anyone who doesn't have a partner, I pair you. Otherwise, I'll give you 100% freedom to choose whom you want to work with. My recommendation, again, out of 22 years of experience, please partner with somebody who has more skill than yourself. Not because others are not good enough, everybody is good enough. But please learn to walk out of your comfort zone. Please unfriend in a good way, not in a bad way. Don't get me wrong. I love every single one of you. Minimize your interaction with somebody who's understanding with life, either personal life or professional life, is exactly the way that you have. Minimize your interaction with somebody who's having the same grade as you. Maybe it's too much, but try to understand the love behind it. If you want to grow, go friend with somebody who has at least one more skill than you know. I know you love to stick to your comfort zone and feel comfortable about somebody who doesn't have anything more than you. But that won't let you grow. You need to push yourself to walk out of that comfort zone. I have thousands of studies, publication, you go yourself even search, that science proved we are and our future is going to be, I would say, an average of the life experience that we are seeing, experiencing, tasting, touching from the first 5% that we have the most interaction with. Choose wisely. Please be scared of choosing your friends. Choose wisely, not because others are bad. It's not about religion, it's not about the culture, not about the skin color, not about the hair color, none of those. We are all the same. All love, we are all love. The thing that I am sharing is beyond this. Unfriend with those who are below your skill. Again, I'm talking only about the skill, either soft or technical skill. Unfriend with those who are equal to you or below where you are standing. And go through. Again, it took me a lifetime to understand this stuff, and now I am talking out of science. If you want to be successful, change your friend zone. That's it. Group with somebody or partner with somebody this semester. If you didn't have the same maybe desired mark last semester, don't partner with the same person. Do not because they are bad, they are lovely, but they do not have enough to share with you, or you do not have enough to share with them. Go partner with somebody who has one skill that you can learn from, or they can learn from you. I think I said it, but hopefully nobody is just understanding it in a wrong way. I'm talking about love. I love every single one. Please do not get me wrong. Okay? Do not get me wrong. I love every single one of you regardless. I close my eyes and I share this. I would love you to progress and get out of this trap. Change your friend zone, okay? So, let's go through the test. I'm gonna have 2 midterm exam. I already informed Moin not to have his midterm exam maybe in the same days, and still I'll check with him because sometimes it happens. So I'm gonna have both of them in the second half of the semester, not the first half, because I want you to have enough time to digest the information, especially get time during the break to review and interact if you need to. I'm gonna have weekly quizzes. In addition to the weekly quizzes, which is random time, not for example, set at 3 or at 4, a random time, right? Anytime that I feel everyone need a break, I'll activate the quiz. You go through it, and it is available only to those who are here. And I take attendance. Anyone out of class cannot do the quizzes. Even if they do it, since I take attendance, I switch it to 0. So it's in class, okay? It's in class. And then we have another type of assessment, which is again just to engage you with the class, which is assignment. But this is again, these assignments which you are going to have 4 of them, 2 in the first half and 2 in the second half. These are different. These are not multiple choices quiz anymore. These are written questions. So anything you are going to experience in test 1 and test 2 and final exam, similar question. I solve during the class time for you. I post the solution for you. Okay? I want you to be in here to listen, learn, interact. These are 2. I try to, I'm not sure if this is recording or not, I try to share the recording in case you want to review. What else I can do? And of course, I'm going to give you option with similar questions that I already solved for you to solve them during the class time, and I'll assign mark to them. I mark them. So you can bring a piece of paper, or I'll print it out. I give you in a piece of paper, complete it, open book. Still, I make it open book. My purpose is you learning, not judging you, okay? So I'm not gonna stress you. I'm gonna provide whatever opportunity that can help you to learn, okay? So I'll give you question, but before that, I solve similar one for you. I'll make it like open book. You finish it, you take a picture from it, you upload it into Avenue, and I'll mark it. How about that? Does that sound okay or terrible? Yes. Yeah? Happy so far? Any question? Anyone wants to drop the course right now? Oh my goodness. No, believe me, I do anything I can do to make sure you have enough references, enough opportunity to learn and practice. And still, that doesn't mean I can guarantee your success. You guarantee your success. So we are going to have a presentation very similar to what I did for mechatronics for your final project. Both of the presentation for the final project and test 2 is going to be pushed to last week. And again, as I said it before, semester will be finished April 7, but we will finish earlier than that. We will finish in the week of March 30. Why is that? Again, because Friday, I believe, let me look at this one, if it is coming up. Okay. This is January. We have one Friday, which is April 3rd. It's a holiday. Therefore, the Friday section, those students who are from the Friday section lab, since you guys do not have this Friday, and this is a holiday, I have no control over it, you guys also are going to demo your project with the Tuesday sections. I'll tell you how later, because here we have no more room. Done. Therefore, every single section are going to finish the project like proposal, demo, whatever, right? Not proposal, demo, right? In March 31st. So March 31st is going to be your final project demo for every section, even the Friday section. And March 30, as you can see it right in here, is going to be your test. And we are going to finish right in there. March 30, test 2, and the day after come, show me your final project. Again, final project, I'm going to bring it to your attention. Any group who's going to have the best final project, I'm going to give you bonus for that. In addition to whatever you have, you get very similar to what I did for mechatronics. But for this one, since I have only one project, I'll give you a bit more bonus. So try to have your best final project. I'll post it on LinkedIn if it is really a good project. I haven't had enough time to post the projects. I posted your pictures, but not the project, but I'll do it soon for the best project of mechatronics. I haven't posted it, but I post, and I give you bonus. And then you can even use those information for your capstone. I have many students, if you know them from last semester, that they used what they learned in this course for their capstone, especially for the motor programming. So this course is really different than other courses, not because I teach it, no, just because the information is really practical and real automotive. That's the only thing, nothing more. So I believe I'm done writing here. I quickly show you one more time. You have 2 documents, okay? All the class requirements, both lab and lecture, the content, everything, even MSAF and everything is in these 2 files. You can find them right out under the outline module, which is right in here. And then even if you need to review them, you can review them on your own as well. I'm gonna pause right in here and collect any of your questions before I start the first lecture. It's your time to talk. It's good that I know you. It's really good that I know you. Yeah. Any question for me? I detect another new face, but I know who was it. Yeah.
Is it just getting class assignments always in this section?
Yeah. Mostly this one, but sometimes the other one. It depends. Some of them, because as I said at the beginning, some you are planning to skip the lecture. See your plan. See, that's the intention, right? That's the intention from day one. I know. I respect your question. You kids are really lovely. That's the thing. Well, it depends. Some of the lectures are long lecture, and they will be ended in 2 sessions in the whole 3 hours. Therefore, I cannot really tell all of them are in the 2-hour lecture. Some of them are there. No worries. Any other funny question? Yeah.
So both quizzes and assignments in class?
In class. In class. You don't have any homework. It's always in class. Even I'm providing proposal preparation to be done in class. You guys are, I think next semester you are gonna finish. I know how much heavy loaded you are in terms of the course. Therefore, I'm trying my best to release too much of work that you have to do out of the class. That's why I bring even the proposal preparation and stuff to the class and to get you to finish it as much as possible during the class.
So both open book as well?
Which one?
Like both the quizzes and assignments are both open book?
Yeah. The purpose in here, as I said, you guys are not primary school students anymore. Very soon we are going to be proud to call you engineer, right? You are next generation of engineers. You've done enough of those stuff. It's time to really learn. Therefore, I don't want to stress for you. I just want a healthy environment, healthy learning environment that you can assess your own learning, not me assessing you, right? You need to learn to trust yourself. Any other question that I can help with? No? Are you okay? Good. So then it's time to start the first lecture. So before I start the first lecture, I'm gonna just one more time. I know some kids, some lovely kids, they don't bother to even go check what they have in here. So I'm gonna help with them with those stuff. You can see under each module, you have lecture slides, always in PDF, okay? And then right underneath, you do have a discussion forum. Kids, what's the best way of learning? Who knows it? Teaching. We can say we are confident with any content if we can teach it to someone else. Otherwise, we don't really know it. We pretend that we know it. If you cannot teach something to me, you don't know it. If you cannot transfer the information, means you don't even have a connection between those information. Those are all around you, but you don't have a connection. Neuroscience, you do not have the neural network for that knowledge if you cannot teach it, right? So now, To help with that, I've created these weekly modules. How do you use them? I cannot push anyone, but I provide the best thing. You have the option to use it or not. You go to the topic, you do have this look at here for every single module, week 1, week 2, and so on. Probably you have heard of discussion forum. If not, this is a discussion forum. You click on go topic. As I said, the best way of learning is teaching. All I want you are done with this one, you are on your way to home. If you are not driving and you are on bus, or maybe if you have few minutes, summarize what you learned, even in 2 lines. Just write in here how. Hit this blue button, which is start a new thread. Like today, for example, is the introduction to microcontroller. Just say, for example, introduction to microcontroller, as I call it IMC. And then in here, short summary of the lecture. In maybe 2-3 lines, 1 paragraph, whatever makes sense to you. Summarize it. Again, not for me, for you. And then scroll down, hit this guy post. You have no one to teach them. Teach me. I'm here to learn from you. I teach it to you, you teach it to me. You don't have to push somebody to sit and listen to you. I sit and listen to you. I go through them, I look at them. If something is not a clear understanding, I'll help you to understand it better next time. This take only probably 2-3 minutes of your time weekly. Each week, summarize your understanding. Again, don't come to me, hey, how do I study? See how many methods I offered? And then closer to midterm. Everybody is ruining test 1, begging for mark. Hey, Dr. Kimia, tell me how do I study better for test 2? Again, I'm repeating the same thing. I don't hide anything from you. I hide nothing. It's not a game. It's a healthy learning environment. I give you everything from day 1. I don't expect you to know something while I didn't teach you. I give you discussion forum. You may not believe it, how much it is helpful. I'll open the door for you to come see me during the lab. Come see me after the lecture on Thursday. I'll give the option to you to email me. I'll give the option during the quiz and assignment. While I'm lecturing, I pause every few minutes and I'll give you option to talk to your classmates, somebody sitting beside you. Just quickly summarize what I said, not summarize how the weather is. Am I gonna be in trouble driving back home? That's not related to what we talked during the class time. Not summarize how terrible was with your fight with your girlfriend last night. That's not for class. Summarize what I tell. Summarize what I'm talking about. Make sense? Is there anything more I can do to help you to understand and learn? Okay. Then these threads, especially if you have closer to test, if you have question for me, post it in here. Why is that? Because when you post it in here, I answer it to here, everyone can see it in case that's a question for others. When you post your summary in here, summary of your understanding, even if I'm busy, I cannot see it and answer it and fix you right in there, your other kids, your other, friends, classmates, TA, I have a TA checking this one, will help you to fix it. Right? So that's the thing. Let's go look at first lecture, which is right in here, introduction about automotive electronic and numbering. So this is the first lecture. It's already 3:18. Therefore, I'm gonna just give you the topic, not the content, and tell you what I'm gonna talk about to have some idea for the second half of the class. I'll give you a break. You go refresh your mind from whatever I said and bring to me any of your questions, then we'll continue. Automotive electronic means nothing about mechanical, for now, nothing about mechanical functionality of the automotive parts. We are going to talk about wiring harness, one by one. Each sensors that we have inside the automotive how we have to program. We don't design sensor. That's not the scope of this course. We don't create them. We don't like the CAD drawing that you do in the other course. That's a different thing, right? In here, we are programming them. We are the boss. We are commanding them how to work for us. So that's the purpose of this course. I introduce every single sensor that we have, components that we have somehow electrically, and in some of them even combination of electrical and mechanical on the dash, inside the car, front, all of them, right? Such as, again, LCD, potentiometer, joystick, I don't know, LED, keypad, motor, temperature sensor, how they work, how they communicate. Can communication, receiving from one sensor, sending it to another sensor, again sending it back to the same sensor, such a conversations. And then, of course, you need to understand the wiring, how we connect them to ECU, electronic control system, which is the brain of the vehicle, like the brain that you have right in here. We are talking about a closed loop system, not open loop. Aren't we a closed loop system as a human? We are. How? Actually, let me summarize something, make it easier for you. Kids, we are the best example of a closed loop control system as a human. A closed loop system has some input, some processor, and output. Input is what? Me as a human. My inputs are my eyes. These are my input sensory. My ears, I can taste, I can smell. These are all my inputs. And my brain for vehicle, ECU, for computer, what is the brain? CPU. So these are planned based on human functionality. They are not coming from out of blue. They build them based on human because we are always the best. We are the master, right? So my input is collecting some information. It will go to my processor, which is my brain. My brain analyzes them. So far, standing here. For the vehicle, information are coming from temperature sensor, I don't know, light sensor, this and that, going to ECU, which is the brain. ECU will process them and sometimes separate them, label them, send them here and there accordingly, which is going to be the output. Output in vehicle is going to be like the motor, speed up, speed down, so signal, turn right, signal left, signal. These are the output. For me as a human output is my arm is moving this way or that way. My legs are moving this way or that way. And that's what we call it the control system. And of course, since this is going to be repeated in a loop, right? And they supposed to continuously, like for example, I'm gonna move from here to there. How do I do it? My eyes will detect which direction and then command my brain, and my brain command my legs. Exactly, this is what we are going to experience in here. I'll practice with you how to command different parts of the vehicle to give you the desired output. So I'm gonna pause. I'll give you like a few minutes of break. We'll resume at 3:30. You're more than welcome to leave if you want to drink something, to whatever, refresh. Few, but still I'm having one available TA position. Of course, I don't prefer to give it to first year students because you are gonna be gone next semester and I have to train another one. But still, I love you. So I'm still having one available TA position. Anyone who did one PR3 with A plus only, A plus students, come see me. And I want it for this semester, and I'll help you with everything myself. But I want you to be fluent, but in a good, like, standing position. A plus students, you can come see me, and we can discuss it. I have one position left. So, ready? You can start it. Yeah. So, let's start the intro to automotive electronic. Look at this picture in here. It might be some old systems, but still very complete, beneficial systems that it can introduce. We are not talking about automotive at this point, generally any control system, any electrical system, or any, I would say, electronic system. Initially, I explained it using human functionality, right? From head to toe is called a control system. I'm going to draw it right in here for you. A control system has some input. Usually we show it like this. This is the input, right? And then those inputs supposed to go to a controller system. Again, if it is computer CPU, if it is automotive ECU, if it is human brain. So I call it just brain. It could be any brain, okay? Or processor. Right after that, this should go to some actuator. Actuator is like what? In human body, actuators are arm, legs, any mechanical movement, right? Any mechanical movement, sometimes it becomes a bit more advanced combination of electrical or mechanical movement. Still, it is called actuator, right? We do have some relays that are fully mechanical relay. And we have some relays, a combination of electrical and mechanical. Definitely you've heard of them, right? So this one is going to be actuator. Right after that, if it is a control system with feedback, of course, it could go through some sensors. Some extra sensors right in here. And then if it is a feedback system, it will go back to the input. Where is the output? Actuator is output. My legs are the final step of the command they are receiving from my brain. Should I move to this direction or the other direction? If it is a temperature sensor, as a sensor, it will detect some information, send it to ECU. ECU send it, for example, if it is your heated seat to heat up. Therefore, this one is going to be output. Now, why do we call it control system? Because it has brain to process, it has sensors to detect, and it has actuator to receive those commands and perform accordingly. Why we call it a closed loop? Because it is going through a process, and this process may be over and over, or let's say continuously, or for a certain amount of time, or certain numbers based on the programmer, may be repeated. That's why we call it a closed loop control system. What's the difference between a closed loop control system and open loop? In open loop, we do not have a feedback system. Whatever we receive, I'm going to draw it right in here. Let's say we have an input. The input is going to the brain, or let's say ECU, CPU, whatever. And then we have some actuator. And then we have output. So everything is happening like this. Nothing's supposed to be triggered. Nothing's supposed to be impacted. Like, for example, this one is receiving one-time command from the ECU, and it will generate something accordingly. But when we have it as a closed loop, this one might boost the functionality, worsen or better. Like if it is a sensor, let's say noise sensor. If there is noise detected through this process, the noise will be back to the brain, or let's say ECU. ECU analyze it with some noise, and it will impact the functionality of the actuator, whatever the actuator is. That's why we call it a closed loop system. Now, having that in mind, let's look at the functionality of electronic systems in, let's say, Apollo 11. Not only vehicle. Every single computer in here include all of those processors, actuators, and sensors. If it is Apollo, also the same thing. If it is like any shuttle, whatever, they do follow the exact component. Maybe the functionality is programmed differently. Maybe they ask this guy to do a different job than what Automotive is doing, but still it's a control system. And most of the time it's a closed loop control. Means functionality of the sensor definitely will either improve the functionality of the actuator, or it will maybe ruin the functionality of the actuator. That's why when you are going to pick your cell phone, or maybe pick up a laptop from any store, some of them are more expensive than other one. Why is that? Definitely, the most important factor is not the brand. It's the functionality of the CPU. How fast it can process the information. Means how many sensors are included in that electronic device, and what is the quality of those sensors. Means which kind of chemical material, mostly chemical in terms of material. Which kind of materials are used in order to build those sensors? Like for example, any capacitor, you may think capacitor is capacitor. Yes, capacitor has only one functionality: to store some energy in the format of a voltage. But it can store more or it can store less based on the material. How is the quality of the material that capacitor is built from? Can hold more voltage, and of course for a longer time, or it can hold less voltage, or for a shorter time. That's why some devices are more expensive. And this is only one example. There are way more than what I am. We have many tiny, tiny electronic devices in this laptop, in your cell phone, or whatever. So the reason behind it is not only brand, if something is more expensive. So this is about what you need to know. All of them, they follow regardless of after this course, after this program, you are going to automotive industry or any other industry, still understanding of a control system, microcontroller, generally programming is a win-win for you. And put it on your CV. I'm telling you, this is gonna secure some, I would say, interviews at least for you. And next semester when we do battery management, especially focused for electric vehicle and generally electric design, I cannot say 100%, but I can guarantee if you have that knowledge and a skill from the next semester course, it's gonna secure a job for you. You know why? Because everybody is right now focusing on electric vehicle design, especially here in Canada, right? Especially after what we have with US, they are looking for more expert in battery. So learn this one as good as you can. I teach you a little bit of battery in here, just a basic maybe knowledge, and then we'll go more advanced. But next semester it's gonna be super fun. I'm gonna change the learning environment. It's not gonna be like your regular classes. Less assessment, more experiments. Less stress, more learning. That's the way I want to say goodbye to you, and then you go to industry. So let's go to the next one. Look at here. Here you can see I've already explained it. We have many different sections in the vehicle. Probably in other courses you have been introduced to some of them, but in here we can see it with more detail. For example, we do have some safety features. Safety features, mostly they are in the dash. Let me just change the color. Most of the safety features are in dash, yes, but they are all connected to ECU. So all of them are receiving command from here. Which kind of other things we have? Like for example, we have sustainability. We have some of them, when I say fun, means they are mostly included in luxury vehicles. They are not really essential for automotive application, or I would say automotive functionality, but if they are, they're perfect, right? So that's why we say these are for fun. For example, driver assistance. Like what? Cruise control. What else? What? Lane departure system. What else? Is luxury feature. Of course, some of these luxury features, guys, is not only for fun or luxury. Some of them are adding more safety to your driving experience as well. So that's another thing. So we have lots of them. Now look at other sensors like tire pressure monitor. You can put it under which category? Tire pressure is safety, right? You have, like, for example, instrument cluster. Anti-lock braking. What is this? Safety. Like, for example, what else? Air conditioning. Air conditioning is a combination of sustainability and fun, right? And so on. So we do have different. So now let's put you in that real experience in automotive industry. When you go there, they may just hire you only for one aspect, focus on one aspect of maybe automotive design, only body. I remember myself when I started for the first time, I remember even I went there first for co-op, then they hired me in automotive. It was the largest automotive company in Middle East. It took me like few months for the co-op, and then they hired me, but still I was a student. They hired me like part-time. Back then, they wanted me to design a brand new side mirror for them with all the electronic system to be automated. Back then, I'm old, you know. Back then, not everything was like super luxury right now. So it was the start of like this stuff. So in there, I was a design engineer initially to only design mirror. Only mirror. So that was the only task I had. Just be an expert in mirror design, not the actual CAD design for the mechanical part of it, like the cap. For the cap, we had another specialist to only design the cap of the mirror. See how much it's like a hospital for everything. You need like an expert. If you are working in a good industry, they have a specialist for every single part of the vehicle. And then later I became more experienced. I was moved to another project, and that was the wire harness. Then I became an expert to only design wire harness. Other people may think, oh, wire harness, why they need just an expert as an engineer, pay them like this much money to just, it's a huge world. We'll be there in the second half of the semester. I'll introduce the wire harness inside the car to you. So by itself is a skill. By itself, I would say, is a completely different engineering that one. Especially, I used to work even in RV industry. RV is a like motorhome. So it's even more complicated. It's not only the wire harness for the actual automotive, you have to manage the wire harness inside the cabin, even everything coming from the appliances and everything. So it becomes even more complicated. So that's why you have to pick your interest, become really expert in that one. Another thing I need you to know about it is, look at here a little bit more detail about human driving, their experiences, and generally, I just said we have different categories like safety, like sustainability, like fun. Why? Because why we need expert for each of those? Because each of those has a huge impact on human driving experience in terms of not only luxury, safety as well. Look at here, I have some numbers in here. Like, for example, most common errors of your grandpa while driving. Okay, so like 86%, they have issue with scan side to side. Scans, that's why they hired just one expert to focus on mirror. How to find out those like black spots that's not really visible to older driver. How to define it or design it in a way that most of the older people, they do not have a clear vision, right? That's why this one is a huge safety concern if they cannot see the automotive right beside them sometimes, not really behind them. They cannot detect it. Therefore, most of the errors is coming from here. That's why they need some sensor which is generating less error than human, or at least it can help and fix some of the human error. Another one which is an important factor, a scan and check rear through the mirror inside, like inside the car, in the middle, right? Another one is when you are trying to detect your car is really inside the lane. That's why we have departure lane. So look at how we can use in sensors, or let's say automated systems, fix many of this. Especially, let's say, if it is dark at night, if it is a slippery, if you are old, or even sometimes young but not having that clear vision, it could happen even to I myself. While I drive, I use even my sunglasses as a prescription sunglasses, because sometimes I cannot clearly see maybe something which is not really close to me. I don't wear prescription sunglasses for normal things, but I do it for driving. So it shouldn't be only like older people. Backup, lane change, a speed regulation, all of this could be fixed, or at least the minimize the risk of failure using a smart system, right? So these are something that you may want to have. These numbers are accurate number, but not the most updated version. When I created the course, these things was the numbers from there, but they will change. They collect more information monthly, yearly, so it could be a little bit with some tolerance, a little bit higher or lower right now. And of course, we are talking about the smart system. A smart system is not something that it could be outdated. It should be updated. And when we have better version of them, of course, the numbers can change and the functionality of the system can improve. Some safety example in here, I already discussed, but one more time. Lane departure warning. This is a safety feature in your vehicle. But lane departure warning is not available to everyone. You're new? Yeah? Yeah. Welcome. So, prevention system, this guy fixing this lane departure system, look at how many crashes we can prevent. Isn't that a really considerable number in here? It is considerable. You have to be proud of yourself when you say, I'm an automotive engineer. It's not only medical doctors that can save human life. It's not, yeah, I do have medical science background. But believe me, us in my engineering science part is sometimes saving more life than my medical science. You go to the street with like not a good car, you kill many people. That's the thing. About battery, I myself finished my PhD in battery design. My topic for my PhD thesis, it was focused on improving functionality of battery for electric vehicle and hybrid electric vehicle. Back then when I was doing that, there wasn't too many battery experts in the market. Not at all. I was the first one who started the battery research in University of Windsor. There was no researcher in there, no graduated back then in battery in there back then. And back then it was the time that every now and then we were seeing in newspapers here and there, not always the hard copy one, that one car exploded. The battery exploded, driver is just dead, many other people around, or maybe the whole vehicle is exploded, other cars crash, other people, another crash, and this and that. So we save life. We save life as an engineer. So, and then look at another number. And here I said, this one, 483K per year. And this one is the number of crashes. So it is really important. Let's look at another part. Look at here, this is about after we started, at around probably around 2010, and after we started designing more smart system. Designing more smart system, fixing more of those errors, saving more life, saving more money, saving more time, all of them. 80% of innovation right now, back then it was only electronic, right now electronic plus battery. Back then we did not have battery, it was only engine, right? So now it's not only electronic alone, it's the functionality of the battery as well. And battery by itself is a combination of electrical, mechanical, chemical, computer. This only unit needs 4 essential engineering understanding. If you are a battery expert, they will welcome you in any field. You are somehow called a mechatronics engineer. I myself am a mechatronic engineer. I can teach electrical, I can teach mechanical, I can teach chemical, and I've never been officially in chemical school. But through battery research, I must learn chemical inside the battery. All the material that makes the functionality of the battery better. Not every material is going to give you the same speed for the vehicle, same safety for the vehicle application, and of course, same storage and maintenance. Therefore, you have to pick the right material. You have to pick the right coolant or thermal management, and that's mechanical. So you have to know mechanical. So that's why if you learn it, you will have definitely good opportunity for finding or securing a job. Look at this. This is the growth from 2010. To 2010. And imagine what happened after 2010. 2010 and so it was still like automated system and electric vehicle are still new. We are talking about 16 years ago. I don't know how old you were back then. Probably still very young. So still things in terms of automated system, smart system, it was new. But compare 1995, this session is only introduction, so some of them might not be really new for you, some of them might be, but it's still beneficial to understand them. So the growth is happening in a way that from 95 to 2010, we have 35%. Now, I don't have the exact number, but I do have the estimation. From 2010 to 2026 is 80 between. This is not exact, but approximately 80%. It's really different. It's really different in terms of automated system, in terms of switching more from mechanical to electrical. Mechanical is not automated. At some point, mechanical, I don't say it will be dissipated. Still, we have like some interaction in the car and stuff which is mechanical based, but at some point, mechanical engineering will change very soon. It won't be anymore the way that we know what mechanical is. Mechanical will not have as point as electrical will, because electrical is making things smart, not mechanical. Therefore, try again, also you are closer to the end of the program, try to focus also. Again, electrical is not easy for everybody to understand. It's like more of imaginary world. That's why many people, they like mechanical more than electrical, because not everybody is enjoying imagining, for example, how current is moving through this wire. It's not something easy. But if you become good in that imagination, you become good in manifestation for life. Naturally, everything is happening through imagination. So, pick any field, especially for your capstone. Pick a project as much as you can. You already started your capstone, right? This semester is your first semester, and next semester is going to be, so it's the beginning of the semester. My word to you from heart. Pick a project that has more electrical than mechanical. Especially if you are planning to, especially if you are planning to use it as a strong point to boost your CV. Pick a project which is more focused on a smart system, electrical design, because in automotive we can pick any of electrical, mechanical, and computer, right? But the thing is, do not try, although I know everybody loves mechanical because again, it is easier, but that won't give you more benefit. Electrical, smart system is something that you can boost your CV with it. So that's experience. You have your free will to choose again. One more time, let's review some of the features, available features. I believe everybody is familiar, but still some of you just are a user and you never look at your vehicle as a designer, as an engineer. It's time to look at your vehicle as an engineer. So we do have 4 main sections in automotive. Again, going back to automotive industry, they do have exactly 4 departments. Each department is in charge of some of this: drivetrain, communication, safety, comfort, or let's say those luxury stuff, right? So later, as an engineer in automotive industry, the only way that you can have your nose in all of them is being a manager. And still, not necessarily a manager is expert in one field or another field. A manager learn how to stick to smart working than hard working. Always engineers are hard working, managers are smart working. So managers are those who figure out how to be a smart, learn a little bit of this, learn a little bit of that, have a good understanding, connect the dot, be able to manage somebody else's mind to work for you. Now figure out whom you want to be. So in this part, digital engine management. Of course, upcoming years, we are not going to have engine management. We have to cross it out. It's not necessary. 2030, right now is 2026. One more time, we'll come to 2026. In 2030, we will not have any regular vehicle in manufacturing, not in the road anymore. No automotive manufacturer is going to build another engine-related vehicle. Everything in 4 years from now is going to be electric vehicle and battery, yes.
A lot of companies took their statements back on that.
They took?
Yeah.
Well, you know what? I understand that. Nobody can say the last word for that. These things are changing every day. If everybody else is moving to smart system, smart city, automated system, and then 1 or 2 company, they do not want to, believe it or not, they will be pushed to. So not my word is the last word, not you, not the other person. But still, up to now, they have that, and you say some of them, they already want, maybe change their mind. But still, that was in the plan. Up to 2030, whatever is existing, but they plan to not to generate more of those for so many different reasons. Gasoline engine, right now still is a challenge. Still we need experts for it, but let's see, hopefully everything will be electronic. Diesel engine, you can see right in here, but still this one is something that has some controller. Controller could be electrical controlling. So electronic ignition, what is it? What's your understanding? I think you had the course with Dan about engine, right? Or you do have it right now. Probably since today is the first day of the semester, you did not have it yet. What is the course? I forgot the name. What course do you have it Dan this semester? Yeah, internal combustion. Usually Dan is coming to teach after me. Do you have class after my class? So it's probably, I remember Thursday after my class, Dan is walking to the same class. Probably it's the Thursday. So, and so on. Communication. Communication has nothing with mechanical. Communication is fully electrical and computer. Communication has a completely separate field of electrical engineering. Electrical engineering is split into few categories: power electronic, right? Communication, electronic, pure electronic, right? So these are the field in electrical, like mechanical. What do we have in mechanical? What do we have? Which kind of mechanical major we have? Solid or fluid? In mechanical, we have two categories. In electrical, we have some universities for majors under electrical. One of them is pure electronic, one of them is power electronic, and one of them is communication. Right? So now safety feature. Let's look at some of the safety feature before we move from here. Like, for example, ABS. You know ABS, right? It's anti-lock brake system. It's in order to look at the brake system and lock it or unlock it as a safety feature. So stability is a sensor. We call it ESP. It is working on stability. It is a programmable sensor. You can pick time and duration, and you can pick the speed and how many data it can collect per second. That will define the accuracy of this system. So, and let's look at here, comfort. Everybody loves this part. I myself love the luxury cars. So adaptive cruise control, maybe even seat adjustment, maybe heated seat, steering wheel seat. These are all luxury options. None of them essential for actual automotive functionality. So now I'm gonna gradually wrap up with some understanding and maybe a little bit of what we are gonna experience together tomorrow during the lab. In the next 15 minutes, we have to wrap up. Look at here. This is the structure of a control unit. This structure is the structure of this computer. Again, regardless of it is a shuttle, it is a automotive, it's a computer, your cell phone, all of them, they do have this structure. The only difference is the number of inputs and outputs. Very similar to the microcontroller that we used to use last semester, which was Arduino. And I said, other microcontroller that might be more expensive, the difference is the number of input output and the speed of processing. Arduino is cheap, not very expensive, because it's limited with the number of input and output, and of course the processor is not as fast as, for example, HSC12 that we are using this semester for automotive application is. That's why it is cheaper, right? So in here we are talking about the same thing. Most of the time we have to send the signal as an input. It will go through some process in the processor. If there is some noise, it will be filtered out, and we will have a smooth output on the other side. This output in here, it could be some ignition coil, it could be electronic throttle, and I'm gonna explain all of this to you in different lectures. Especially this part is going to be the second half of the semester. It could be fuel injection. These are different outputs connected to this same microcontroller in the lab. Tomorrow in the lab, we are focusing on two things. I'm gonna give you the setup. Right now I have the TA sitting in there. Check all the setups and make sure the functionality are okay, to make sure tomorrow you are gonna have a smooth experience. Tomorrow I'll show you first the setup. I'll introduce to you which kind of parts you have included. You do not have to purchase anything this semester, okay? No purchasing. I've already have everything in there for you. I'll give it to you, and I'll want it exactly the way I give it to you, okay? Because especially this semester we have more students. I really want everybody to take care of the setups. When they go bad, and we don't have option to fix them. Inputs are going to be right in there. I've already included the essential inputs in the setup. They are already attached. Still, for the final project, you can bring your setup for mechatronic cars and add more sensor if you would like to, but that's not necessary. I already have enough sensors in there. That's just an option. Again, tomorrow I'll introduce the outputs of that setup. That setup is supposed to simulate the actual vehicle. Like what you see on your dash is gonna be your LCD. What you are gonna see, like for example, in the signal left and right, is a combination of your LEDs and LCD. I'm gonna teach you how to draw an arrow on your LCD to signal left or to signal, how to program LCD to do so, how to program your keypad to lock the door or unlock the door, like those kid locks and so on. So again, you are going to look at the processor. RAM is always another important factor of the price of any microcontroller or any electronic system. Why is that? Again, not only because of the brand. Space. How big is that space? Of course, again, material. How the quality of material can impact the speed of the processing, right? So that's why some of the microcontrollers are more expensive than the other one. So we are going to learn about like the priority of the signals on the microcontroller. There are situations microcontroller is receiving few different commands at the same time, but still it cannot process all of them at the same time. Therefore, microcontroller supposed to have some internal program in order to categorize which signals should go first, which one should be treated first than the other one, which we call it flag, right? We have to flag the signals and give them priority order. For example, reset, regardless if it is a software or if it is a hardware, if you press the reset button on your system or if you send it as a command through the software, always priority. Regardless of how complex is the process that you are going through and how long you have worked on that, if a reset command is coming, the microcontroller is going to reset. If you press it, it's going to reset. Because that's the first priority inside the debugger. Debugger is built in. You don't do it. There are situations you purchase microcontroller and then you purchase debugger. That's a different story. But what we have is a patch. You don't have to, let's say, simplify it as a translator. Every microcontroller needs a translator. And that one is what sometimes you have to purchase it separately. Here you can see for computing again, we have major and minor. These subs are the minors. This little one, subsystems. In electronic design, we really call them subsystems. These subsystems are the minor systems which are having only one task in the process, only one impact in the process. So why we call them minor? Because sometimes if one of them goes bad, one of them is in error, it won't impact the functionality of the other one. That's why we call it minor. Because this one is not going to control, for example, the functionality of this one. This may go bad like a fuse. There are situations we can have bad fuse, only one feature stop working, not the rest of the vehicle. Still the rest are functional, are fully functional. That's why we call that one a minor. But there are situations that a major part is impacted for any reason. It could be mechanical, it could be software, which is more of electrical. So that's why majors are, for example, dynamic safety. Dynamic safety, if this is a major part. Torque management is a major. Body security is a major. Driver interface is a major. Anything like this, small parts in here, like seats, mirror. Seats can be faulty, but being a faulty, like having a faulty seat, that doesn't mean that For example, navigation is faulty. Maybe my heated seat is not heating up properly. It doesn't impact the functionality of my engine. So that's why we call this one. Some of them are major, some of them are minor. And then right in here, we are gonna finish it up. This is a big picture about what this course is going to teach us. We are going to practice in this course one more time. First half of the semester, and I'll finish it right in here. First half of the semester, we are working on embedded system. As you can see it in the next slide, the topic is showing embedded system, is focusing on control system, programming, and what you're supposed to do in order to make the sensors to communicate to each other. Of course, still in first week of the second half of the semester, I'll help you with CAN communication. But right after that, years back, this course was super heavy, almost 17 lectures. They designed it initially that way. 17, I swear not even 17, 18. 18 lectures to be given to students in only 11 weeks. Means some of the weeks, they supposed to learn 3 lectures. That was horrible. So then I have to redesign it. Especially this semester, I took off any unnecessary. And mostly I added assignments and any possible way that you can interact and learn and practice instead of just be loaded with lots of theory that you will forget right after you walk out of the class. That doesn't have point. Still, I created some lecture for you for review, which you can review it on your own. I created some quizzes for you to review on your own. Some of them in class 1 graded. The one that which is out of class, no grade. Just review and become prepared for the final exam. Test and final exam, both midterms. And final exam, you do have both theory question and problem solving, both of them. That's why I quiz you to become prepared for that. So first half of the semester, we are focused on intelligent system. Intelligent system means more of programming, get to know sensors, how to connect them, how to program them. Means intelligent system. Second half of the system, more focus on mechanical application. Means learn about throttle, learn about brake, learn about how to fix some faulty situation about your battery, how to, I don't know, if your battery is gone, how to recharge it, how to connect 2 cars to charge one using the other one. I'll teach all of this practically. Yes, I am a girl, but I know this stuff. So, like temperature control, cruise control, even I used to give a student airbag and this stuff, but you don't need all of those. So if we don't talk about those anymore, not because those are not useful, simply because that's too much. 18, that's too much. So this is a big picture. I'm gonna just finish it up right in here, which is a big picture of the course. Tomorrow I'll see you during the lab time. You will have lab mark every week. Try to have your partner in advance. If not, no worries at all. One more time, friendly. Partner with somebody different. Enjoy and we'll see you tomorrow.
I have the same lab as you. 8:30? Yes.